Hi and a very good day. So for this video session, I will show to you on how to model a linear regression by using Eviews. Okay, what will you learn in this video session? Okay, I will demonstrate to you on how to divide your observation into modeling and evaluation part. And after that, I will show to you on how to perform basic linear regression analysis by using Eviews. Okay, suppose that for this demonstration, I will use the same dataset as the previous video. Okay, so let's do the first step before we model the linear regression. Okay, as I mentioned before this, we need to divide our observation into modeling and evaluation part. So for this tutorial, I will use the first 24 observation from January 2010 to December 2011 as my modeling part, and the last 6 observation from January 2012 until June 2012 as my evaluation part. Okay, it can be done by clicking sample here, right? And this is where we specify our sample. Okay, as I mentioned before this, January 2010, so 2010, until December 2011. Okay, now instead of all observation, my sample is only consists of 24 observation. So when I estimate my linear model after this, my estimation only consists this 24 observation. Okay, so how to perform a linear regression model? Just click quick here, and select estimate equation, and a window will open to specify your model. Make sure that this model, the estimation method is least square method, and the sample is the same as our specification here. So basically, alternatively, you also can change the sample period using this session. Now, as we mentioned before this, our dependent variable is demand. So you have to type your dependent variable first, followed by your constant variable. And next, suppose that I want to demonstrate to you simple linear regression. I just want to include one independent variable, so I select price, and I just click OK. Right, so basically this is the output for our model. So as we can see here, generally this model is in a good fit as the F statistic give a significant value. Suppose that we use the level of significance 0.05, since the p-value here is less than 0.05. We say that our model is good generally. And when we check the coefficient, price will give a negative coefficient in explaining demand, and the coefficient also significant. And next we check the goodness of fit. As we can see here, the R square give only 0.183, is actually quite low. It means that price only explain 18.4% total variation in demand. The information is not enough. And as we can see from the Durbin-Watson value here, actually our model have positive serial correlation. Right, so we might consider to add another variable. So we can re-estimate by clicking this, right, estimate. Maybe we want to include average industrial price in our model. And click OK. So what happened? Again, our F statistic does not have any problem. because it gives you a significant value. And now, okay, both our coefficient also significant, and our R square value is increased compared to before this. Okay, price and average industrial price, okay, explain 86.32% of the total variation in demand. Okay, but as we can see here for Durbin-Watson, okay, we have a negative serial correlation because our Durbin-Watson value is greater than 2. Okay, we also can save this output. Okay, name it as, okay, I will consider this as model 2. Okay, the first model is model 1 and this is model 2. Right, okay. Okay, since that we have a few more variable, okay, I want to add another variable which is, okay, advertisement expenditure. Right, so I click OK. Okay, now this is the output. If I include one more variable, okay, we can compare with the previous model. Okay, suppose that I name this as my model 3. Okay, so as we can see here, okay, the Durbin-Watson value is improved because the Durbin-Watson value now near to 2 compared to the previous model. Okay, but still I will say that we have less serious negative serial correlation. Our adjusted R square also okay, bigger than previous, okay, previous model. Okay, and basically we don't have any insignificant coefficient. Okay, so I will compare the performance of model 2 and model 3. Okay, so suppose that I name this as my model 3. Alright, okay, so how can we evaluate our model? Okay, so next I need you to click the forecast here. Okay, when we click the forecast, we actually want to okay, we want to estimate our model. And okay, now, okay, suppose that this is model 3, I name our forecast name as model 3 and I click OK. Okay, before I click OK, remember we left our last 6 observation to evaluate our model performance. So for the forecast sample, I need you to specify it. Okay, 2012 1 and 2012 06 and click OK. Sorry, forecast, okay, M3 2012 M01 2012 M06. Right, okay, so you will get this output. Okay, now freeze and save this output as, okay, evaluation M3. Okay, click OK. Right, and now I need we need to focus for this model, okay, for model 2. So okay, click estimate, remove this variable, click OK, and then click forecast. Okay, model 2, and now the forecast sample also we need to change. Okay, so that to make sure that it only consists of the evaluation part. Click OK. Right, freeze and save. Okay, name it as, okay, evaluation M2. Right, okay. Okay, now, okay, we can compare model 2 and model 3. Okay, we can compare model 1 and model 2 and model 3 here. Okay, so as we can see here, okay, based on error measurement criterion here, okay, okay, model 3 have lower RMSE, okay, because model 3 give 0.26 compared to model 2, which is 0.413. Lower MAE and also lower MAPE. So based on this evaluation, I will say the best model to estimate demand is model 3. Right? So that's how we perform basic linear regression analysis by using Eviews. Right. Okay, suppose that additionally, okay, we also can check check the residual residual properties of our model. Okay, suppose that we want to check the constant variant assumption. Okay, we can choose this option, okay, residual diagnostic, okay, heteroscedastic test. Okay, suppose that I select here Bruch-Pagan Guthrie test, right? And we check whether it is give the p-value more than 0.05 or greater than 0.05. Okay, p-value greater than 0.05 emphasize that our model have an equal variance. Okay, this dependent variable is for residual square. Okay, this is output for Bruch-Pagan Guthrie test. Okay, and we also Eviews also can give VIF output, variant inflation factor output, okay, which we see from the center VIF here. Okay, so I think for demonstrating basic linear regression, it is that's all for me. Alright, okay, so again, any feedback you can straight contact me or you can subscribe my YouTube channel. Right, thank you again for listening and watching. See you again. Thank you. Bye.